This is navigation for glider and TMG pilots, part 3. And in this part, we're talking about navigating in a TMG rather than a glider. So, unlike in a glider, in a TMG we can fly a particular heading and speed. So we navigate in the same way as in a powered aeroplane. We use moving map GPS as our primary means of navigation, and we back it up with map reading and dead reckoning skills. So how do we do that? Well, we can estimate headings and times and mark up a map. We're doing this manually, and it's probably good enough to do it manually if we're using a GPS as our primary means of navigation. We can work out our maximum drift, and for TMG that's roughly wind speed. So here's the formula for maximum drift. It's wind speed times 60 over the true airspeed in degrees. And a TMG cruising at 70 knots is pretty close to 60 knots. So the maximum drift is roughly the same as the wind speed. So 15 knots of wind speed, our maximum drift is going to be 15 degrees or thereabouts. So then we can calculate the drift component using the clock code, which we covered in part 1. Our ground speed, on the other hand, is going to be 70 knots plus or minus our tailwind or headwind. And remember that at 60 knots we do 1 mile a minute. So on the ground, before we could go, we can work out roughly what our ground speed is and therefore how much time each leg takes. And when we mark up our map, we put on the wind and the wind speed, so we know what the maximum drift is. And then for each leg, we can have a set of boxes like this. And on here, we have the true track that we want to achieve for this leg, so it's 067 degrees true. We have the magnetic heading that we're going to need to fly that, so 062 degrees magnetic. There's a little bit of drift from the left, 5 degrees worth. The altitude we're going to fly at and the time the leg is going to take. And we've got some space to write something in there, which might be an update of the time. And then you can see that we've put some fixes. So we've decided that as we cross the A1M here, that's a good opportunity for a fix. And our estimate is that it'll happen 12 minutes into this leg. So this is an example of a line fix, which can tell us how we're doing in terms of in terms of the distance we've travelled on this leg. It's not very good at telling us where we are, left or right, and we're going to have to make an estimate by looking at Connington and Alconbury. As we do that, we want to be midway between the two, but it's going to tell us quite accurately what our speed is doing in relation to what we thought it was going to be. So we've done that for each of the leg, and here's a map marked up which would allow us to fly without using the GPS if it were necessary. Or we can use a flight plan app, for example SkyDemon, which is a really good example of such a thing. I really would recommend that to anybody doing any serious amounts of VFR or IFR power flying. So here's the route that we've just been discussing, marked up in SkyDemon. You can see the map presentation is a little different from a 500,000, but it's fine for these purposes. And we're going Caxton, Rushton, Ramsey, and back to Granston. And this produces a PLOG or pilot log for us, which we can print out if we want, or is available on the whatever device we're using it on in the air. So it gives us our route. It gives us a minimum safe altitude, which it's calculated according to however we've set that up, the level that we've decided to fly at, the indicated airspeed we've chosen for the aeroplane, and from all that, it's worked out our true track. We've put the wind in, which it will, if we do this planning within the day or so, it will use the forecast winds. Otherwise, we can specify what wind we want to use. And from that, it gives us a magnetic heading to fly, a ground speed that we're going to achieve, and the time that will be taken. Very usefully, it puts all the radio frequencies that we might use for that trip underneath. So those are available too. So really good app. We can use it in the air to monitor our progress, and that's really helpful too. Going back to paper maps though, which we're going to use as a backup, there are some ways that we can make these easier to read. I've talked a little bit about them, but you can see that I've used a round circle around the turning points, and if we're flying and map reading, that's quite helpful rather than putting a big splodge of pen over the detail of the turning point. We've got the fixed lines we talked about earlier. We've got the boxes, which we can use for a number of things. And I've got enough of the map that if I go off my track, I can still find out where I am. So mark up your map, fold it properly, tape it down so it doesn't unfold on you in the air. I'm also a great fan of navigating track up rather than north up. So I'll hold the map so that the picture outside the aeroplane corresponds to what I see on the map, and vice versa. So back to the thing that we're normally doing, which is flying the route using GPS. What are the priorities? Well, the first priority is lookout. We manage our workload so that most of the time, just like in a glider, we're looking out. After that, we're holding heading, altitude, and speed. If we're flying heading, we're going to fly it visually. So supposing we're flying 285 degrees, that's the heading we want, we'll use the compass or heading indicator to make sure that we're doing that, and then we'll pick a point on the horizon, which is the thing that we fly towards in order to keep that heading, and that's what we use primarily then to fly the heading. Just referring back to the compass or direction indicator momentarily during our instrument scan as part of our lookout scan. So again, we're not eyes in focusing on the map or the instruments. If we're flying a track, by which I mean we don't have a good heading indicator, then again we'll fly the heading visually and adjust that so the track turns out right. If we're using a GPS, actually that's easier than having to fly a heading and adjust for wind. So with a GPS, particularly the sort of thing that would be either SkyDemon or an UDI or anything like that, we can generally line up the track line or achieve track line with the track line that we want, and that adjusts for wind automatically. So that's really useful. But still, the technique is to look outside, pick a point on the horizon, point at that, and not obsess about what the GPS is seeing. So that's what we're doing here. With a moving map, just align the track to the required track. Frida checks are important. So regularly, every 10 minutes or so, we're going to be doing Frida checks. And every time we pick up a map or look at the GPS, good lookout first and look out afterwards. And the key is enjoy the flying. There's actually plenty of time at these speeds. So the navigation tasks we're doing happen every 5 or 10 minutes. The Frida checks are happening every 10 minutes. There's plenty of time to look out and enjoy the view. The second priorities of navigation tasks, though, things that we're going to do along the way. So when we set our heading initially at a turn point, there's a good mnemonic which is TTT. We turn onto the new heading and check that that's right. We note the time. Either if we're flying with a stopwatch, we reset the stopwatch and start from 0 for the time for that leg, or we note the time that we're going past. If we're using GPS, then that will probably update automatically for us. And we may need to make a transmission to tell air traffic, if they've asked us to report at that turn point, that we're there. So we do a transmission. So Turn, time, transmit, a really good thing anytime you go through a turn point. We do something called a gross error check. So the first task after we've passed the starting waypoint, we've done our TTT, is have a look and check that it all looks right. Is the heading the same thing that we've got on our PLOG or on our map? Is the sun in the right place? Do the basic features look right? You know, if graphene water is meant to be on your right, is graphene water on the right? Traditionally, a classic mistake of people is to set off on a reciprocal heading and just go the wrong way, and that's not good. When we come to fixes, so these are places partway down our leg after 10 minutes or so, where we're going to check that we're exactly where we are. We look for the fix. So we've looked on the map for what we're looking for. We find those features on the ground. And once we've found them, we do a careful check, so cross-check with other features. We can evaluate if we're off track, how far we're off track. And we've got a 10-degree fan line on the maps to help us do that. And then the recommended technique is to get yourself back on track. So fly towards the fix, put yourself where you should be. We can then calculate the adjustment to the magnetic heading. So how far off track were we? And note that. And then over the fix, note the time, which will give us a new estimate for the end of the leg, or the next fix, however that works, and turn onto the adjusted heading. So if we found that if we've been using a heading indicator of some sort, a compass or a direction indicator, and we've drifted to the left by 5 degrees, say, then we can make a reasonable assumption that the wind is different from that which we anticipated, so we can make have a new heading that we're going to use, which is 5 degrees to the right of the original one, to compensate for that drift. If, on the other hand, we've been flying using a track, then we still want the track that we had planned. That hasn't changed. But we might want to think about why we drifted. Was it because we were flying inaccurately? And think about that. So far as timing goes, having prepared an elapsed time over each fix, we then can compare the actual time over the fix and make an adjustment if necessary. So if we thought we should get to that fix at 10 minutes, say, into the leg, and we are 12 minutes, then we're 20% slower than we should have been. And so if the end of the leg is meant to be at 20 minutes, it's now going to be probably 24, unless we change our speed to compensate. We don't have a lot of flexibility about changing speed in the TMG, so we're probably just going to make a re-estimate. We can write the times, either using the watch or the clock from the GPS, over each fix as a time, and then we can recalculate other ones. What we're going to do is going to depend a bit on which equipment we're carrying. If we're flying without a moving map, now we don't recommend doing that. I think if we're cross-country in a glider or a TMG, we should be using a moving map. But supposing it's failed for some reason, we're completely dependent on accurate flying and fixes. So we need to closely monitor the heading and the track and the timing, and we need to be very careful about fix identification. It's really easy to misidentify a village as something as a different village. We need things with very clear features that allow us to uniquely identify them. And it's much better to pick a small number of those every 10 or 15 minutes down your route, rather than try and use lots of small things that are easy to miss. So wind farms, for example, there are so many wind farms around, they're not a great feature, but they might be a useful feature to positively identify some other thing with other features. If we're flying with a DI and compass rather than using a GPS track, then we're going to be flying a heading on that instrument, and we're going to make allowance for wind. So if we do that at fixes, we must estimate the track error and then reacquire the track and fly the new heading, allowing for that track error. If we're using GPS, depends a bit on what sort of GPS we're using. There are much less so these days, but there are GPSs which just give us a few numbers: a current track, a track to the fix, a distance to the fix. If we're using those, we very much need to combine those with a PLOG and a map in order to fly safely. Be careful if that's the case. If you do a diversion, for example, and you just do go to somewhere else, watch airspace, because that sort of GPS is probably not going to tell you much about the airspace. If we're using a more modern, decent GPS with a moving map, it's very important to have a good backup. If we're flying with something installed or fixed on the panel or on a mount in the glider, you know, like an iPad with SkyDemon, then maybe carry something on your phone that, in the event of the primary GPS going down, you can pull that out and use it. I carry SkyDemon on my phone as well as on an iPad, and you can also, of course, use a paper map as a backup. Which is a good thing to do, certainly when you're at early stages. We're monitoring map to ground, so we're looking at the map, looking for features on the map and checking that they're happening on the ground, and we're flying visually and looking out. Really important. Dead reckoning, so the backup that we are going to use if everything else fails. It's great fun, actually, but it's a particular set of skills which require a lot of practice. And on the TMG course, we won't be giving you that much practice. Maybe you want to do that later. The key to dead reckoning, though, is accurate flying, both heading and speed. Then you need to manage your workload carefully. So we're spending most of our time looking out and doing aircraft and engine management. They're very important. And then relatively little time actually doing navigation tasks. We're not doing the pilotage that we would do in a glider, that is flying around with a thumb on the map, knowing at all times where we are in relation to features on the ground. Rather, we're picking times where we ought to be able to find particular features. And at those fixes, both line and track fixes, we make an assessment of any error and its cause. Is it inaccurate flying? Is it an incorrect wind estimation? And then we make a correction as appropriate. So with the track error, we move back onto track and adjust the heading. And if it's a time error, we correct the anticipated arrival time. Be really careful about misidentifying fixes. So pick fixes that won't be misidentified. Let's talk a little bit about how it can all go wrong. Supposing the weather deteriorates. We're making the assumption that neither you nor the glider are instrument qualified. So if the weather gets bad, what do you do? Well, a really good thing to do is turn around. If the weather deterioration is sudden, it's frontal, for example, or big showers, big line of showers, then turning around and getting out of there is often a really good thing to do. If the cloud base is coming down, then the obvious threat and errors are obstacles and terrain. People fly into the ground regularly, and that's not a good idea. We can make use of the minimum safe altitude. And there are various methods of calculating that. If you look at SkyDemon, you can change the settings to make that different, but an easy way of doing that is to take the highest grid obstacle on the 500,000 chart and add 500 feet. It's perfectly allowable to fly below the minimum safe altitude if you are VFR and you know where the obstacles are and the visibility is reasonable, I should probably say. So if flying below the MSA, you must be pretty certain of your position. That MSA is going to keep you safe from hitting things. The next option is to divert. You've got the option of diverting, do it early, because it's much easier than trying to do it when you're getting stressed because the weather's getting really bad. If you can use the GPS, that will help you, particularly if you've got good airspace in there. So you can, if that's not available, you can draw a line from the current position to the diversion airfield, following the line features. You can then compare the track from a VOR rose on the 500,000 map and estimate the distance using the 10 nautical mile thumb. You know, your thumb, this bit here is about 10 nautical miles on a 500,000 map. So that will give you a reasonable distance and bearing estimate, but it's quite tricky. Once you've estimated the new track for a diversion, make an adjustment for the estimated drift to give you the heading to fly, or if you've got a GPS track, you're going to be using that, you don't need to make the heading. And you can do that because you know the max drift, and you've written that on the map, and therefore you can work out the heading. And likewise, you can make an estimate of your ground speed, given that you know where the wind is coming from, and therefore how long this leg is going to take you. And that will take you to your diversion. A few other things to think about in this event. You've probably got some turbulence. The lower down, you're going to get turbulence. Topographical turbulence, built-up areas, big trees and things if you really are there. Also thermal turbulence. So that can be an issue that can make life a bit more difficult. And map reading is going to become more difficult. At low levels and in poor visibility, you can't see as many features as normal. They go past more quickly, and small things that aren't on the map appear big. So you can get lots of villages and that can confuse you. But hold the calculated heading and time, and don't panic if you haven't seen a decent feature for a few minutes. Look, use the things that you are going to recognize, the bigger towns, the bigger roads, big pieces of water, and wait for them to appear. You can follow a line feature, of course. If you build in a known area to your heading or track, you can look for a major road or a railway line, and then you'll know which direction to turn to get to somewhere where you know. You're going to be looking at the map more often if you're not using a GPS, so hold the map up high so you can look at as well, and hold it track up as well. That's very helpful. In terms of vertical situational awareness, particularly avoidance of controlled flight into terrain and airspace, you really want to maintain the MSA or above, but if it's impossible and the visibility is poor, it might be better to do a precautionary landing, especially if you come across a suitable airfield on the way. If you're low, think about ATZs and danger and restrictive and prohibitive areas when flying at lower levels than planned. If you haven't planned to be low, you might not have looked at all those, so pay attention. Be careful a bit about noise sensitive areas. That ought to have been part of your flight planning, but following a diversion in poor weather, you're less likely to be so well prepared. Remember, the priority is to land safely, and the TMG is fairly quiet, so don't worry too much about it. The focus on flying safely. However, you mustn't fly over built-up areas at a level so low that you can't glide clear in case of an engine failure. So flying around towns and cities is often the only safe course of action. And note the 1,000 foot rule. You mustn't be less than 1,000 feet above a built-up area, and you mustn't be less than 500 feet from anything, any person, vehicle, vessel and structure. If you're lost, if you think you're in danger of infringing airspace and you know roughly where you are, head away from it, or put the glider on the ground safely. If you can try and establish your position, do so. That works better if you're higher, but don't hesitate to call London Centre on 121.5, especially if you're close to controlled airspace. They're really helpful. You can tell them you're uncertain of your position, you can ask for a training fix, and they will give you vectors, so headings, tracks to fly, back to where you want to go. They're really helpful, they like the practice, just call.